I'm Anil Kumar, and here is a basic question on higher order derivatives. We'll try to understand the displacement equation. The question here is an object moves in a straight line and its position s in meters after t seconds is s of t equals to t square minus 16t, where t is between 0 to 10. Describe the motion of this object. So what we are given here is displacement function, which is s of t equals to t square minus 16t, and time period is from 0 to 10 seconds, right? So the units are seconds for time and meters for displacement. So let us first find velocity and acceleration. So velocity is derivative of displacement. So it is 2t minus 16. We could write this in factored form. That helps. If I take 2 common, I get t minus 8. Okay. Let's also find acceleration. So acceleration is derivative of velocity. So that is 2. So what we notice here is that the acceleration is constant. It's always 2 during this period 0 to 10, right? Now we'll analyze velocity and see how to describe this particular displacement. Now velocity for us is 2 times t minus 8. So let me sketch a graph for velocity on the right side. So these are all approximate graphs, but they will help you to understand the basic concept. So here we have 2 times t minus 16. Let us say this is horizontal axis, this time t in seconds, and we have velocity in meters per second. Now the velocity intercept is 16, slope is 2. So if I write t as 0, I get a point minus 16 here, so that is minus 16. So initial velocity for us is minus 16. And when is it 0? It will be 0 at t equals to 8, right? So at t equals to 8, it will be 0. So I can draw graph of the line kind of like this, right? We need to stop somewhere since the limit is 0 to 10. So let us find what is the velocity at 10. So if I substitute 10 here, I get 2 times 10 minus 8, which is 4, right? So this is at 8, and at 10, let us say this is 10 for us. So this is 4 for us, okay? So our graph is actually from 16 minus to 4. So that is the graph for velocity. So as far as the velocity is concerned, let us see how to describe the velocity function now, okay? So we have initial velocity as minus 16 meters per second. Now when we say minus, that means the object is moving left, right? So on a straight line, we are saying the object is moving left, and that shows minus 16, right? That is what negative velocity reflects. Now as it approaches the point at, or you could say it is going to south, okay? So the negative velocity is left or south. It could be either way. So object is moving in this direction. So, and at this point, what really happens is that the velocity is 0. So at t equals to 8, velocity is 0. And at t equals to 10, the velocity is 4, right? All are in meters per second. Now what really it means that 0 velocity means a turning point, right? So if I'm drawing a linear graph, let me now sketch a linear graph and show it kind of, I could show it here also. So initially what is happening here is that the object moves towards left like this, right? Do you see that? And it moves towards left for 8 seconds. Do you see that? So this is the initial position, and at this position t is equals to 0, v is equals to minus 16 meters per second, and for 8 seconds it moves here, and there it turns and then moves back to positive direction. Do you see that? So that is kind of the movement which we have. So this turning point is at t equals to 0 when, t equals to 8, okay, when velocity is 0. So velocity is 0 means, this really means it is the turning point. Negative velocity means left, moving left. And positive means moving right. Right? In different ways, you could also say negative velocity means approaching and positive means going away. You could say that also, right? So going away or approaching. That is another way of looking into this, right? Now that gives us insight to displacement. So from the displacement function, we can relate this. If you see the displacement function s of t, let's look into that in further details. S of t is equals to t square minus 16t. So we could factor t out. So once you factor t, you get t minus 16. Now, this is a quadratic function where displacement is 0 at t equals to 0 and at t equals to 16. However, displacement is maximum at t equals to 8. So we can substitute 8 here and find the displacement. So it will be 8 minus 16, which is 8 times 8, 64, right? So what we can also say here, that during this time of 8 seconds, the object travels a distance of 64 meters, right? So in 8 seconds, object travels displacement. This is 64 meters, right? Now, minus, I should have written minus here, minus 64 because it is moving backwards towards left side. So we say S equals to minus 64. Okay, so that is the distance traveled in first 8 seconds. We can write here, in first 8 seconds, object travels 64 meters left. So that is minus 64 meters, right? These are very important to understand. Now, we have to see what happens in the next 2 seconds, right? So let us find the position at 10. So if I substitute 10 here, I get 10. You could do either one of those equations. 10 minus 16, and that's 60, right? So it is minus 60 meters, right? So at this time, it is 60 meters away. So this position is 60 meters. So at this time, displacement at this time is equals to 60. It's still negative, so the object is still on the left side of where it is starting, correct? And at that time, the velocity is 4 meters per second at this time. So at time, so let's consider what happens at t equals to 10. That is at the end of the cycle, right? At the end of the cycle, what we found is that the velocity is 4 meters per second. That means object is moving right. Displacement S is minus 60 meters per second. So it has moved right 4 meters, right? So that means this unit, so let me make a bigger scale here. So we have an object which starts from here, kind of goes there and then goes backwards. Do you see that? So that is the position at t. So this is at t equals to 0. Now as far as the position vectors, we can displace, this reflects position. That means S of t, right? So it is minus 64 at t equals to 8. And here it is minus 60 at t equals to 10, right? So that is how the position is. So object is actually on the left side of the starting point, so negative 60, even at the end of the 10 seconds, right? So, and during all this, what we also find is that the acceleration during this time is constant, and all throughout acceleration is 2 meters per second square. So during this time we can write acceleration A equals to 2 meters per second square when time is between 0 to 10 seconds. Is it okay? So that is how you can describe acceleration. As far as the position is concerned, so the position actually changes from initial position of 0, since it moves leftwards for 8 seconds. So it is minus 64 meters, and then in next 4 seconds the object approaches the starting point, covers 4 meters, right? Now from such questions there is one more question for you, and your question is find the total distance traveled. So your question here is find distance traveled. I'm not saying displacement. Distance traveled in first 10 seconds. So that is the question for you to do. So you can pause the video, answer the question. And the answer for this is total distance traveled is 64 meters plus 4, because this distance is 4 meters, right? So the total distance is 64 meters plus 4 meters, and that is 68 meters. So during the first 10 seconds, object travels a total distance of 68 meters, right? So I hope with this you understand how to represent velocity, how to represent, that's a displacement along the horizontal line, right? So this is, I can write here displacement along straight line or horizontal line, right? Straight line, okay? So that is the displacement graph for you, that is velocity graph for you, and acceleration is, as you know, 2. So let me just draw a graph here for acceleration. That is acceleration A equals to 2 meters per second square. Of course, we should have drawn them separately, but on the same scale you could kind of represent it, right? So I hope with this you understand. When the question is describe the motion, what should we say, right? So find velocity and acceleration from displacement. Discuss when is velocity negative or positive. What does it mean? So it means going towards the left. Positive means going towards right. Okay. Now in this case, we found that in first 8 seconds the object moves towards the left. At the 8th second, it turns, and at the turning point always the velocity will be 0, right? And then it moves right with the velocity of 4 meters per second, covering a distance of 4 meters. I hope all this explains you very clearly how to describe the motion of an object along a straight line, and also see how to sketch these graphs, right? So these are kind of important graphs to work with. Thank you and all the best.